My iPad here says it's 3:30, so let's get started. My name is Doug Gerolds. I'm with General Dynamics Mission Systems, and I'll introduce what we're doing in the big data world here in a little bit. But we're here with a mini panel discussion on the topic of achieving high performance results from Accumulo and other open source big data frameworks, and that's the topic for a mini panel discussion. Our panel members are up at the table, and rather than have me introduce them and read from their bios, I'm going to have them introduce themselves just real quickly here. So let's start on this end of the table.
Hello? Oh.
It appears to work.
Yeah. So hi, my name is Josh. I'm a employee at Hortonworks. My sort of history is I've been a long-term committer and user and all sorts of other things with Accumulo itself. Since going to Hortonworks, I've quite a sort of branched out in lots of other technology, regular delving into Hadoop core itself, Yarn, working on things like Slider, and most recently, HBase. And I guess non-professionally, I've kind of been a long-term advocate of open source, so doing development in open spaces, contributing the work that you do, share and share alike, that mantra.
Hello. Good afternoon. I'm Jim Maltby from Cray Inc. I've been working in high-performance computing for about 27 years, primarily in applications development, and I've been with Cray for about 15 years. Let me see. I've worked on various systems at Cray, but just recently Cray has been moving into the analytics space, and I helped develop a semantic database RDF store on one of our supercomputers. And now we have a big project at Cray to migrate Hadoop and Spark to our really big iron systems. So I'm working with that, and Accumulo is an important part of that.
Hi. I'm Bill Leinberger. I'm with General Dynamics. We go back as far as control data government systems. So we have a legacy of building mission-specific high-performance computing systems, starting at the application and working down to the silicon. So my background is actually hardware design and system design for HPC hardware. And we're moving into analytics too. We do a lot of work with application space in the application space of our customers. Analytics is their next big area, so obviously we're going to follow along. And my goal is to find out if HPC hardware is relevant in the data analytics world. So once I found out it was written in Java, that called all that into question. So I think there's some discussion to go on here. So that's what we're going to do.
I like the test first methodology there on the microphone. So jealousy up here already. I said I didn't think of it. So my name is at the bottom there. I'm Doug Gerolds. I'm a technical lead in the HPC group for General Dynamics Mission Systems. As I was packing up to leave on this trip, my son asked me, so where are you going? And I pulled up the website, and he was very impressed. He said, wow, Dad, you're big time. I didn't tell, I just appreciate that opportunity to leave that impression with a teenage son, so that's a good thing. I didn't tell him I'm not that big time. I just like to find really smart guys and ask them a lot of questions and then pull a plan together. That's kind of my role in the last 10 years with General Dynamics. So that's my self-introduction. How's that? So just a little bit of introduction. Our panel topics, we want to discuss the merits and procedures of standing up open source big data frameworks and capabilities like Accumulo on HPC-class systems. And when we talk about HPC-class, we're talking supercomputers like Cray or an SGI or an IBM machine or something like that. And we want to share best practices for identifying bottlenecks, improving performance, and working with the open source community. And we've done some of this. We've got a demo out at the table outside the door here. We can talk to you about in the work we've done with Hadoop and Hama. And really what we want to do is see if there's low-hanging fruit or opportunities to go after on Accumulo in this sort of vein. So that's our introduction to the panel topics. Whenever we get out in these public forums, we like to introduce the fact that, as Bill said, we've had a group working in high-performance computing for quite a while, and our current focus is investigating and investing in ways to maximize analytic performance, taking advantage of HPC capabilities. So really, we want to leverage the power of high-performance computing, leverage the productivity of big data analytic capabilities and frameworks. This community has done a really good job of enabling distributed computing in a very productive manner, getting people to be productive very, very quickly. And so we think if you can marry that, those frameworks, stand them up, get the performance that you can get out of a high-performance computing platform, you could have the best of both worlds, of productivity and the performance. Our case study that we can talk about at the table in more detail was a study that was in a paper that was presented at the Supercomputing Conference back in November. I was talking to somebody that's already 6 months ago. But what we did is we took some Twitter data. Everybody likes Twitter data. It's open and pretty easy to get a hold of. So we took 8 million unique users, 40 million tweets. We did some graph analytics on it using the Apache HAMA framework, Hadoop, and then we looked at, well, how could we make this go faster? We took that framework, we took those applications, we put them on an HPC-class system, a large InfiniBand connected cluster, and then we went in and surgically replaced about 1% of the code in there and got a 10x speed up. So we have a little demo on that. And then in the Department of Shameless Self-Promotion, you can come see a visualization of that graph analysis where we have 8 million users and those tweets all in one graph on a display with 1 million pixels. Well, you can dive in and look at that. Anyway, with that, I'm going to start asking the questions. I'm going to ask a couple questions to our panel members. They can respond as they wish. And then I'll, as you listen to the discussion, if you have further questions, we'll open the floor to questions as well. So you can come to the microphone or speak loudly. So the first question. If you assume that high-performance computing platform key strengths are things like high-performance networks, fast and deep node memory, fast parallel sync and reduction hardware, and parallel file systems, what are the current performance bottlenecks in Accumulo that might be addressed by this kind of technology? And I'll let you fight over the mic.
So most likely the lowest hanging fruit of those is, that would be directly applicable if you go down and pull Apache off of the source from Apache itself is most likely going to be at the network layer. Because of the abstractions that we have at the RPC, we're typically not dealing with how the implementation of reading or writing from a socket actually works. I feel like there's been some experiments that have been done where people have used InfiniBand, so special networking equipment to achieve a higher throughput. Within Hadoop itself, if you're writing, the ability to read and write data from data nodes across your network is pretty important for actually the perceived throughput that you have from a client or a server as it is. One of the things that Hadoop actually really harps on a lot is the effective locality. So when you're actually doing some operation, say you're reading from a table, where on your network? Is it rack local? Is it on the same node? Is it across a different rack? So how many hops do you have to make to actually read the data that you want to do? Each hop, you're going to have some perceived latency incurred there. And ultimately, if you can shorten that, the long tail will probably sort of shorten down. Hopefully that would be the desired effect if you're paying for something that is more than commodity hardware.
Yeah, I guess my favorite amongst all those choices would be the fast and deep node memory. Our systems have always, and most HPC systems actually always work entirely out of memory. They don't tend to have local disk. As a matter of fact, I can't think of one that does. So a lot of our optimization for HPC systems is avoiding any sort of I/O calls at all and keeping things in memory, which takes quite a bit of local memory. The parallel file systems, we're very proud of our high-performance parallel file systems, but they represent somewhat of a problem for Hadoop and Spark, since, as was mentioned, people try to move the calculation to the data. And all of the data in the parallel file system is off on a separate machine, so is off on a separate box. So try to work around that, as I say, by keeping as much as we possibly can in memory. But, and third, I would certainly say that high-performance networks are and their special features, synchronization and RDMA, have been very useful.
I got nothing after that, but Josh mentioned that the word socket. Well, that's the first mistake. HPC people don't use sockets. InfiniBand is not a special network; it's actually a commodity network. So, that's the difference in opinion or viewpoints when you come from an HPC world versus a commodity world. But he is right. The networking is probably the first place that you look. The next one is using the high performance file systems, Lustre, GPFS, whatever. Memories, I'll go one step further and say, why not put everything in memory and throw out the disks? Just don't even need them. I mean, when we're talking about customers that we go for, we're government contractors. They have memories that approach half a petabyte or a petabyte in DRAM. So, HPC would say, put it all in DRAM, use checkpointing to get your resiliency, things like that. So it depends on what your level of pain threshold is how far you want to go with these, what HPC can do for you. Not what's wrong with Accumulo, but what are the opportunities where the technology can get you. So that's about it. I think we covered them all. The last one is, almost every one of these frameworks has some notion of a central controller somewhere. Accumulo has it in its master server. That sort of thing is a bottleneck, no matter what the design is. When you scale up high enough, and getting away from single thing. HDFS has its name node. Things like that are just bottlenecks. And HPC practices, they don't do that. So I take it from what does HPC have, not as what's wrong with Accumulo. I don't. One of the things Accumulo does great is memory management. They've fixed that problem. So you start with what HPC has and how you could leverage it into Accumulo rather than the other way around. Explanation point.
It's like pounding the gavel, I think. Are there any follow-up questions from anybody on anything you heard there? Yeah. So let me try to summarize that. When you go from the sequential system is developed and you move to a big shared memory type supercomputer, what has to change, or is there a lot of change that has to happen there? Is that kind of the...
There's an overlap of what kind of falls apart.
You got it? What's the overlap? What kind of falls apart?
Sure.
Sure, I'll address that. We do have some systems that are extremely large shared memory, and so in that case, you take a very different approach to design and simply maintain all your data structures like that. However, that still only scales up to terabytes of memory and not petabytes for a very large system. So when we're dealing with our large parallel file systems, you have to change your tuning and also change the size of all your reads and writes. You may need some sort of intermediate buffer cache. We sometimes call them burst buffers in between your main system and your parallel file system in order to cache reads and writes and avoid so much traffic on the parallel file system. So what you mentioned is indeed one of the big challenges we have. It's one of the basic architectural differences. So I can't say we figured out yet, but those are some of the things we're working on. Yeah.
So I'm going to go back to putting everything in memory. One of the most interesting uses of Accumulo is to have this double index where you kind of read one table and index into another, and now you've got random access of your mutations, essentially. If everything's in memory, that doesn't matter. All of a sudden, you're going to get things at memory speed rather than at sequential disk access speed. So it actually forgives a lot of problems at the cost of a big shared memory system. But if performance is your goal, that's the kind of things you can look forward to. So otherwise, parallel file systems, the advantage there is there are you have just as much bandwidth going out to them, but the sequential access nature is still there, and you do have to be careful about how that happens. And like Jim said, the buffering is probably more important there because you have to worry about congestion in the network out to the thing. So.
Okay.
Actually, I have I'll ask my own follow-on question since you mentioned it earlier. You had mentioned Gluster. So Gluster, my familiarity with it doesn't extend much more than outside of what is advertised sort of as a Hadoop compatible file system. I'm curious if either of you can more expand on how the architecture of Gluster would actually replace something like HDFS and how it would overcome some of the barriers that you would see.
I don't know anything about Luster. I was talking about Luster.
I have no idea if Luster is actually also has any Hadoop compatible bindings.
Well, so I'll talk to Luster a little bit. First of all, there's no single name node. There's a distributed name node, so the access doesn't choke through that. Second, resiliency. There's no such thing as replication. You don't need to do that. That's just wasting space and power, actually. Third, in an HPC system, you don't have disks on your node, so you have to use something like Luster, so it's kind of a prerequisite. Let's see what else is there. Other than that, I think it has all the same advantages. It's pretty easy to manage, to add volumes, things like that. It's I would say it's just as much easy to use. So.
One more. Since you brought it up again, the replication, it's easy to sort of, Hadoop takes, I guess, an easy approach to the problem by saying, well, if we replicate this data, we can handle failure. But typically, my understanding is that you still have some sort of error correction or some sort of can you expand on that a little bit? Either of you?
Certainly, I suppose I should not everyone in the audience might be that familiar with HPC hardware, but typically it's the racks are filled with nothing but high-performance nodes that are basically each decent-sized SMP computers in their own right. So each node will have a large amount of shared memory with 24, 32 cores attached to it. There'll be tens to hundreds of thousands of these nodes tied together with an extremely high-performance network. There might be hundreds of cabinets. These are all tied to via a large number of parallel channels to this Luster high-performance file system. So there's a very large amount of bandwidth on and off the file system, but it is then a single file system.
One more question.
Yeah.
But for resiliency, though, I mean, that's what RAIDs are for. That's what they're meant to do. So you lose a disk, the RAID is going to rebuild it over time as you replace it, hot swap. So for that, that's why I say you don't need replication. You go to a NetApp box, it's the same thing. They run a Hadoop appliance with their NetApp, and they just turn replication off because their RAIDs are so reliable. You don't have to worry about that sort of thing. So again, it's the JBOT system is there for a reason. It's a low-cost, commodity alternative that you can keep track of technology. HPC is going to cost you. All these things cost you, but the benefit is hopefully performance if your mission needs it. So.
All right, I better stop before I get another question from up here. Are there any other questions from the audience that somebody has they want to ask? If not, I'll seed with another question here. If you were migrating Accumulo to a specific HPC platform, how would you measure or characterize potential performance bottlenecks? How would you go about identifying those so you can knock them down?
Well, you start with benchmarking, of course, and tracing, instrumentation, and gathering performance statistics. So coming up a representative data set, your representative key definition, and the type of queries you're going to make, the type of ingest you're going to do, that's all key. That'll give you an idea of where your application design is going to go from a performance point of view and where it's spending its time and what piece you need to think about changing. Then you move down into the micro benchmarking where you create data sets and queries that just characterize that piece of Accumulo, like the client to server transfers or the server side filtering, whatever you want to do. And then you go in and say, well, what can HPC do for me there? And then you go fix it. Fixing it means looking at the code, changing the code, testing the code, and going back to your original benchmark, and then ultimately your application space, and then testing it again to see if you've made performance gains. And all this is predicated on the fact that where you're spending your time is a significant point or percentage of your total timeline that makes it worthwhile to do that effort. So you really got to take this all with a grain of salt. If there's no performance standouts, and then you don't really want to go too far into the Accumulo and make too many changes. So that's the short answer.
Covered it? I don't see any hands. Just stick your hand up if you want to interject with a question. See, my next question would be, okay, if you've gone through that process, I've got a couple over here. Let's go over here for a question from the audience. So I'm going to repeat the question, just because I imagine there's some over here that can't hear it. The question is, in a prior session, there was discussion of a capability called htrace for tracing. The question is, does that fit in an HPC environment, or is there another approach? Did I capture your question? Very good.
Sure. Hypothetically, I wouldn't see any reason why htrace wouldn't be able to be implemented in whatever the code that is wrapping the HPC system, right? This is all kind of predicated on there is some sort of amount of code that allows Accumulo to work on an HPC-class system. I think it's kind of taken as an assumption, hypothetical. htrace itself is just a library. It has an API. You can call it. You instrument methods which hit your write or read path. These are essentially serialized into a store. This can either be an Accumulo table or it can be an external process. But essentially, it's a distributed store. That can take information about a path. And there's some trickery to actually, like you were saying, going from a client down to a server to another server and sort of coalesce this all in one view. So without getting into specifics, I wouldn't know why something like htrace, it's just like any other tracing library. It should be able to work across whatever software you write, as long as you implement it as such.
I'm sorry I missed the talk, but in the HPC world, for many years, there have been a lot of different tracing applications developed, and that is one of the first things that you really need in order to optimize performance. So perhaps I can chat with you about it afterwards. But HPC's been around for a while, and a lot of performance tools have been developed, and they're very, very useful, and we use them to get to extremely high percentages of peak capacity of the machines. And so I think that open source analytics are a little younger, but I'm pleased to see that such tools are being brought up.
Yeah, so from a tracing point of view, timing is one thing. Another metric that's really useful is memory utilization as you go through these systems. Java is notorious for chewing up memory, and you don't really realize it until it's too late. So, if tracing could be extended to not just tracing, but and keeping track of time, but also aggregation of those times and aggregation of other metrics that you want to measure, like memory utilization or counts of packets or counts of messages or counts of whatever. Counters are a more general way to do what I would call HPC tracing. So it's a good start. And we've got Accumulo running on a couple of different HPC systems. It works fine. We haven't tried any of the tracing, but it's worth a try. So.
All right. Any others from the audience?
So we just used MapReduce and wrote a parser, and it was a pretty stable. Yeah, and it runs in seconds. So.
Oh, so you didn't do special like this Stanford natural language processing?
Well, that's for sentiment analysis, and we actually have Josh. You could probably address that. Another GD guy. They've done more work on Twitter sentiment analysis. That's where you get into more of the processing side of things, and from a processing point of view, HPC only has a few things that might be better than a commodity system. We're using the same x86 processors, but they're usually more high-end. We usually get more memory bandwidth, and then there's always the accelerators that we all love, and like GPUs or things like that. So, but as far as the processing, we haven't looked. That's more the Josh's group. If you want to talk to him about that kind of thing. So we were just looking at, hashtags and retweets and basically structure of the social network rather than the content of the sentiments.
So, yeah, the specifics on this you guys could talk about after we're done in here too. As we're talking about here, to take advantage of HPC, specific capabilities, if you're making modifications to open source software to, take advantage of those things, how do you maintain your HPC relevant modifications back in the open source community?
That can be quite a challenge sometimes, because sometimes we have things that are immediately relevant to the open source community, and other times they are not at all useful. For example, in our semantic database, it's front-ended with Apache Jena, open source database, and we are contributors to the Apache Jena product and have made significant upgrades and stuff to the front end, Jena. But our back end is based on proprietary processors that are only sold by Cray, called Threadstorm, and they're programmed in our own strange version of C++. So open sourcing that would be of no actual use that would give us a warm feeling. So Cray uses open source software across our entire line, but in some cases it's immediately relevant to the community. In other cases, it's not immediately useful.
Okay.
Or did you have a?
I've always got something to say. So one of we have this is what's really holding us up from contributing anything back is we don't know, first of all, how relevant it is. I mean, how many people care about, if we ripped out the communication RPC at HAMA and replaced it with InfiniBand verbs layer, how many people care about that? How many people could even test that on their system? How many people have access to an HPC system where they could rebuild or reproduce what we did? That's kind of a big concern. And that testing, and then there's the business case of, can we actually do ongoing support? That's kind of holding us back. So it's actually hard for a government contractor to do this on, we don't see the path forward on why this is a good business case yet. But we'd like to know, because we would like to leverage the open source, and we'd like to put things out there for the IBM torrent network, making use of that thing. How many people have access to that? Well, maybe they've got access to the payment layer, but not the torrent layer. So it is a question of access. But even some of the projects we've worked with, running on a commodity cluster, how many of those projects have been tested on something more than a 32-node system? We're testing on hundreds of node systems, and they don't work. They fall down and break, and it's because they weren't tested thoroughly. So I think HPC adds challenges from a sustainment point of view that makes us hard to put our customizations back into open source and hope to get anything out of it. So that's probably one of the biggest impediments we have.
So there's a couple things I'd like to address. One is that it's definitely, you mentioned so there's an ownership question, right? So if you're a contractor, you're working a service, you have some contract that has some specified deliverables, and you're giving that to a customer. Typically, the customer will retain those rights because, well, they paid you for it. One of the interesting things that's sort of coming out of this whole open source movement, we're really seeing it come out of at least the startup world with Hortonworks itself, Cloudera, MapR. They're all contributing to these various different projects, typically through the Apache Software Foundation, although if not there, it's permissively licensed on a GitHub or something like that. And it's really representing this, at least how I naively see it in the industry, a sort of a paradigm shift. So it's not something that, if you want something that works, you don't have to go to a vendor and buy something from them. Personally, there is some amount of code that will get you somewhere that you can just go and actually use, download, and say, like you said, well, maybe it won't work in all your cases. Maybe somebody only tested on 5 nodes. Maybe it works to 1,000. It's a different environment, and I think what you're slowly starting to see, and I think the fact that we're here today at all, is sign that certain individuals have recognized that there is value to trying to contribute this stuff back to open source. 5 years ago, if you probably would have asked Aaron Cordova or Adam Fuchs, who gave the keynote today, they probably would have said, oh, this stuff we're working on is never going to be open source. We're never going to be able to work on this. And through the dedication of a few very special individuals, here we are today. And is the community better off for it? Personally, I think so. Anything that isn't developed in a bubble definitely has the potential to sort of grow and become better. And I think as people have itches to scratch, and they scratch those itches, that's when your software gets better. And I think that's sort of one of the long-term tenets of open source. If you have something out there enough and somebody really wants to solve a problem with it, they will contribute the code back to you, and then it's a matter of community actually working together to find a way to do it that satisfies everyone's interests.
Bill would like.
Oh, yes, sorry.
So I just want to reemphasize, you made a good point there on when we most of our work, 95% of our work is customer funded, and they retain the rights to that. So one of the things we have to figure out how to do is to get our customers to realize the value of letting us put their work back into the open source. And that's always a touchy thing that you have to plan out ahead of time, and we're still trying to figure that out. So if anybody has a good idea there of how you convince, the civil agencies or the DOD or, DOE, that we're going to do work for you and then we're going to give it away to everybody else too. And I'm not saying that, I think that there is value in that, and we have to convince them of that ahead of time. So when we write these contracts going in, we know how to separate our IP, their sensitivities from what we can actually contribute back. And I think that's one of our challenges to making a business case for becoming an open source contributor as a corporation. So.
Okay, we're just about a minute or two left. I want to give one last opportunity for any questions from the floor. I see a hand in the back.
Any HPC initiative on exascale streaming data analytics?
So any HPC initiative on exascale streaming analytics?
Let me see. We are certainly have several exascale projects, and we are working on streaming analytics. We have not, it's early days on exascale, so I think if we can stream data at a high rate into our petascale systems, then we'd be doing pretty well. So our streaming data efforts are starting on our cluster level systems, which is closest to standard Hadoop or Spark setup. And we do have very high performance I/O in and out of our petascale systems.
Anybody else? Very quickly question. Let's go over here since he's already had one. Yeah. Okay. Very quickly, because we are about out of time.
Very quickly, we're very enthusiastic about Spark, significantly more so than Hadoop. It offers significantly more complex communication patterns. Hadoop basically came from a world of relatively slow, simple networks and a large number of essentially uncoupled tasks. Our computers are made with complex networks with complex protocols, and we think we have more room to grow with Spark. We are working very closely with NERSC and the Spark developers to try to get it working on HPC. So we're sort of hanging our hat on Spark, I should say. We're optimistic for its future.
I know it is a new kid on the block.
Well, and Cray isn't naturally a fad-following company, so it's not that. It's just that the characteristics of Spark data structures and communications appear that they'll work much better for us.
Bill or Josh, do you have anything quickly on that topic?
No.
Well, I added the quickly. That's what did him in. We are at time here, so I want to thank the audience for your participation. I want to thank the panelists here for their contribution, and then in 10 minutes, Josh is back up here for the next talk. So thank you very much.